basically like they're both called coaxial circles, but one's in chapter 2, one's in chapter 5. Okay, so chapter 2.3 is called coaxial circles. Okay, and when we say coaxial, we mean like the radical axis. Yeah. So, so basically, the two circles have the same radical axis, right? They're coaxial, and you get a whole family of circles that have the same radical axis. Yeah. So basically, you have this equation: x squared plus y squared. Have you seen this? Minus 2ax plus c equals 0. So the c is fixed, okay? And a varies, yeah? So this is meant to parameterize a whole family of circles as a varies. That have the same radical axis, okay? And I think the idea is the radical axis is the y-axis, yeah? Alright. So the radical axis is the y-axis. And you see these circles all have center on the x-axis, right? Yeah. So the radical axis is perpendicular to the line going the centers. And the center is always at A, yeah? That makes sense? Is that always a positive A? Yeah. So if you maybe you can convince yourself first that these circles all have the same radical axis, yeah? So for example, you get a circle centered A, yeah? We took a point here, yeah? Any point here, yeah? Maybe we can say that's B. What would be the power of that point? With respect to that stuff. So the circle has this equation, yeah? Yeah, so the radius, I'll do it for you, it should be like, the square of the radius should be a squared minus c, yeah? Yeah? Complete the square, yeah? So x squared minus a squared minus c, yeah? So d squared minus
like you find a point like that, and then not keep open.
yeah.
Yeah, no, that's Can you just say about that? You find the relationship immediately, and it's something that they use as well. Like, yeah,
So the power is like d squared minus r squared, right? D squared is b squared plus a squared. Yeah. Minus a squared plus c, right?
It's d squared.
D squared is the distance.
Wow.
It's a squared plus b squared, right?
Yeah.
So this is equal to b squared plus c, yeah? Yeah, so that's good. Yeah. So the A is not dependent on A, right? So the power at this point B is going to be the same for all the circles. It's always going to be equal to b squared plus c. Yeah? You change another point, it'll be equal to, you know what I mean? That's the whole point of this radical axis. Every point has the same power with all the circles. Okay? So every point has the same power with all the circles. You might wonder, can you see that they're all of this form? They're all of this form, I guess, because, so that, I guess all you have to see that they're all of this form, right? You just basically need to see that for every different point here, there's only one circle that could have that as the radical axis, like with the other circles, right? Yeah. So if you fix the center, right, and this point, right, you're basically saying there's only one radius that could make it work, yeah? Because the distance is fixed, right? Yeah. Well, the distance is fixed, and B is fixed, and C is fixed, right? Then there's only one radius that would make it work. Yeah? So this is a description of all the circles which have radical axis to y-axis. Yeah? And it actually covers quite a lot. It's not just it's just not just the ones that like, so can you see, depending on what C is, you can see what case you're in. Can you see there's kind of like fundamentally, like, how many different cases are there? You know? Like, how many different cases are there for C? Yeah, so C equals 0 is one of them, yeah? And you see what that corresponds to? Yeah. Yeah. So that means it touches, right? Tangent. So another way of thinking about it is C is the y-intercept, yeah? Yeah, so basically, whenever C is positive, right, you can't have a y-intercept. Yeah? Because 0, like y squared can't be negative. Yeah? If x is 0, right, y squared has to be positive. Okay? But that already tells you, so the case we were in before, I guess you're kind of subconsciously thinking it doesn't intersect, right? So that's when C is negative, yeah? When C is positive, I mean, yeah? And so you already kind of thought of C as positive, probably. And then the radius is something a little bit less than A. Yeah, so I guess these are the cases, right? There's the case where it doesn't touch, the case where it's tangent, and the case where it kind of touches, you know, two points. Yeah. Yeah, there'll be two y-intercepts. Okay. Yeah, like negative root C and plus root C. Yeah? Huh? Oh yeah, so when A disappeared when you said x equals 0.
Yeah.
But on the other parts, yeah, A is still there. A is the center. Yeah? And they're on both sides, right? Because it's symmetric. If you reflect it, it still has the same radical axis. Yeah? Is that all we wanted to say? Yeah, so we call this a pencil of coaxial circles, okay? Have you heard the word pencil before? Like in this context? I think we'll also see it again when we do projective geometry. We have like pencil of parallel lines. I don't know. I just can't remember jargon. Jargon just. I can't even remember stuff like I've done research on. I think it's like too like traumatic to remember. If you remember it, like your brain will just be like, why are you remembering this really specific thing for this long? I've already written it down, just forget it. Okay, so all the circles consist. Yeah, so when it has these intercepts, right, that's an easy way to deal with, right? Because they're just all the circles that go through these 2 points, right? For a circle to go through these 2 points, the center has to be on the x-axis, yeah? So that's the kind of the case we weren't really even dealing with, but we dealt with. And then the other cases, that's when it's interesting because we had an interesting question before. So what happens to the radical axis of 2 circles that don't intersect, right? And they're not necessarily concentric, and they're inside one of each other, right? They're nested, and that's what happens, right? Because so in this case, if you draw out some circles, you get like a lot of these things happening, So the centers kind of move, and the radius is also adjust. Okay. So I think this covers all the cases for families of coaxial circles. Okay. So what does it say in the book? So A varies over all the real numbers except when C is positive. Then it only varies between plus or minus root C. This family is called a pencil of coaxial circles because every 2 of its members have the same line of centers and the same radical axis. Oh. Should we mention something about the same centers line? Yeah, I guess in principle you can have 2 circles up there and they would have the same radical axis. Right? So you want them to line up in the center. Illustrates. Yeah, see the picture in the book is like this, like magnetic fields or something. Yeah. Okay, that's it. That's 2.3.